Oh, it just started recording. Great. Okay. Well, we won't have that UML in there, so sorry about that. Hopefully, this will now continue to record the rest of this. So, if you take a look at that UML diagram that I wrote and shared through my iPad, I will go ahead and share that out on Canvas as well, so that you can have that or put that somewhere. I'll maybe make a better UML diagram for this particular one and associate it into these slides. Maybe that's what I'll do. So again, the attributes being in that middle section, the methods being in the bottom section. Let me share that out one more time just so that we can see that. If it didn't get recorded, all of that. All right, so there's that UML diagram. Again, the name of the class here, the attributes inside of here, and then the classes here. Remember that the plus is for a public, minus is for a private, and then static is indicated with the underline under the item. So this is a static variable. This is a static method here. All right. Man, I keep hitting that mute button in the worst spot on this thing. Okay, so getting back to here, we've got this circle class here. Let me make sure I've got everything so I can see all any questions. All right. Okay, so if we identify one static variable from the circle class, that variable is the circle count. And it's the count of the number of circle objects that we've created. So what we're doing is we're giving ourselves a tally of how many circles we have in existence. So when we create this class and then start creating actual circle objects, every time we create a circle object, we're going to up this circle count. So that's what the purpose of this. So one example of where the scope of the variable is private, so it cannot be used outside of the class without calling it to within the class, from within the class. So we could not access this as a circle count. We would have to go get circle count and use this method here that we've written as a static method to get the circle count. So I'll show you that in code in a little bit. So what is the one instance variable from the class? One of the instance variables is the radius, and that's the radius of the circle, and its scope is private, and it can't be used outside the class either. So we have to, if we want to get the radius, we have to use a getter. So this get radius here. So again, this scope idea of if it's static or non-static. If it's static, then we can access this method by doing a dot notation. So circle dot get circle count. That would give us the actual circle count for the from the class and call this accessor or this getter. So that's the idea there. This is kind of a chart of all that. So all of these things are kind of described in here, and we've got different local variables inside of here too, and parameters that we're passing into there. So make sure you understand this. This is going to be a pretty important one to understand the difference between static and non-static, to understand the difference between public and private, and then to understand where these things can be called and how you would call them. So we've got this swap driver that we're going to look at here. I'm going to share out some code here. Let's go to example circle. So this is that circle class. I've brought this up in Eclipse and previously done something with it. So let's go ahead and look at this here and then look at this swap driver. So inside the swap driver, we're setting up two integers. Then we're going to print them out before the swap. We're going to run this swap ints, which should swap the values of these two. And then we're going to say after swap and print out A and B values again. So then after that, we're going to go over here and swap the circle radii. So we're going to take a circle called first and then a circle called second, and we're going to set one of the radius to 7 and one of them to 4. Then we're going to do a before swap and print them, and then an after swap and print them. And then we're going to, down here, access the circle count by calling it, and this is how you would call it, circle.getCircleCount, and this will tell us how many circles were created. And if you run this, this is the output that you'll get over here. This before swap, you're going to have integers of 7 and 4. Inside the swap ints, we're going to swap integers 7 and 4, finish swapping 4 and 7. Then the after the swap is interesting because out here, these A and B are still 7 and 4. We've only swapped them inside of the swap int method because we pass them in as parameters. These parameters never change. So inside of the actual method here, we are only changing the values inside the method, not outside the method. So this is a demonstration of this swap ints down here. We have set up a new X and a Y. X and Y are getting swapped here, but when we come back to here, we have not swapped the A and the B out here. So make sure you're understanding that and that you're noting that inside this method here, the swap ints method, we've got an X and a Y. These are getting swapped. These values are being changed. But outside of here, the values that we passed in, the A and the B, are not getting swapped. So we have A and B still remaining the same. So this is a scope kind of demonstration and an example to see what the scope of variables is and where we're changing them. This X and the Y. In here, we could have actually called these A and B as well. Then we could have really confused things, and you would have thought A and B were getting swapped in here, but they are not. That's why we called these X and Y, so that you could kind of see explicitly these are different variables. These parameters that get passed in are not the same. And this is why you don't want to do a whole lot of changing of these parameters, because weird things can happen if you start doing that. So that's why in check style, we always suggest against doing this, because it's not a good practice. In other words, you could have some issues you'd run into if you are doing this kind of a swap and then wind up confusing things. All right. So then over here in the swap circles, before the swap, we've got a 7 and a 4. Inside the swap, we're swapping circles 7 and 4. And then finish the swap, it's 4 and 7. So C1 and C2 inside of here have switched out items here. And after the swap in here, because we're working with objects, these objects are pointing to the same thing. So with an object swap here, we're actually going to get this to be changed because we are actually working with the same C1 and C2 because we're passing the reference in to these instead of just passing in the actual variable value. So this was creating a new variable value because this is a primitive type for int. This over here is actually an object, and so these objects point to the same thing. So when we change these two and swap them inside of this method, we're actually swapping the actual values here. So note the difference between this primitive swap and then this reference variable type swap. The reference variable type will actually make that swap both inside the swap method, and outside in our main method here, or in our driver method here. So again, take note of that. Then back here, the final thing is this get circle count, and we created 2 circles because we got 1 circle here and another here. So that's 2 circles created overall. So, all right. Over here, let's take a look at another class here. We're going to look at these color and the point class here. Again, 3 attributes here for the color class. We've got a red, green, and blue. They're ints. We looked at this the other day in that color lab. So we've got, and these are private. They're non-static, so they're not underlined here. And then we've got over here a point class X and a Y. We worked with this in the homework 10 quite a bit. And you should hopefully be familiar with this one by now. This is a pretty standard fare. Again, we've got our constructor here and then explicit two explicit constructors. So you're not limited to one explicit constructor. You can have more than one. So this is a X and Y point that we're passing a value, or we're creating a point from another point here. Same thing with creating a color from another color, or creating a color with red, green, blue values. So this only has two, so there is no default constructor, so to speak. So this has two explicit constructors in this one for the color object. All right. So as we look at this, we identify the accessor method in the point class. Ooh, moved way too fast there. Accessor method in the point class. What we're going to see down here is that in 8, getX is a getter or accessor that the getX the x value, and it takes the x value out, and it is having no parameters passed to it, and it has an int value that is returning. Then in number 9 here, we've got a mutator method from the point class. That's going to be the set y, and it sets the y variable. And it will be passed an int value that you want to set that y to, and then it is going to have nothing as its return method for the method. It's going to do some things here, but it's not going to actually return back to the user anything when it's getting called. All right. Then in this credit card design, there's more on this, and you can see the UML diagram example for the credit card that's out on the website. I won't go into more detail on that one. This is available out there. I would go through some of these pieces again to make sure you understand all of those. Go ahead and correct that while I'm at it. All right. So that's pretty much what I wanted to cover for lecture material. Let's go into now this mower. I'm going to take this mower here, and let's go from the UML over to some code now. So from this UML, we know we're creating a mower class. I'm going to go ahead and do this in Eclipse. I'll actually I've got one created, but I'm going to go ahead and create one from scratch just so we can see this process once again inside of Eclipse so that there's no doubt how to do this. So File, New Java Project, and I want to go mower as my project name. Oh, so I need mower as the project example. And I want to make sure I have my project folder as root for sources and class files. Then I'm going to hit next and hit finish. Okay, so I've got this mower example. And over here, I want to do a new Java class. I'm going to create this new class. I'm going to call it the mower. And I'm going to generate comments here. And I don't think I want anything else. Again, we want to use that default class or default package here. And then I'm going to hit finish. That's going to create me a new class here. I'm going to get rid of this extraneous comment up here. Then I'll come into here and create documentation here. And for 1420. And all right. And inside of here, I'm going to create my mower. This is going to be my default mower constructor. And you want to label your constructors pretty explicitly. Okay, so what do I want to do inside of here? Inside of my mower, I need to create some attributes. Let's go ahead and do that. And let's go ahead and go out to here and see what attributes are that we want to create. We need this mower. I'm going to go ahead and pull this over to here so I can see both of things at the same time. Yes, okay. So what we want in this mower is we want a string that is the model and this is going to be a private, and it's going to be non-static. So private string model, and then we've got a double, and this is a private one again, double, and it's called gas level. This is for a lawnmower, if you haven't figured this out already, and it's going to basically be the model of the mower and then the gas level that we have. This is a very simple class. We're probably oversimplifying this class into something that is way too simple, but we'll go ahead and do that for now. String M is what we're going to do for our constructor. And then we're going to go double G for gas level. And this one is going to be a public because it's a plus sign there. And we're going to go non-static here because we want to create an object. And that we are returning a void on that one, so we don't have any return pieces here. And then we'll want to write this method, and we'll do that in a minute here. Let's just go ahead and set up all of these stubs for this. So we'll go get model. This will be our getter for our model. We'll go public, get model, and we'll need a void here. Or actually, we'll need a string here that we want to return. And that is it for that. And then we want to go ahead and do this, and we want to return. Actually, let me just write this one. This one's so simple. Return model. Or in this case, this dot model. All right, so let's do this one as the next one, and we're going to go get gas level. And we're going to write this one out. This one will be a public again, as all of our methods are in this one, because we don't really care too much about the information here. So let's say get gas level. And we're not passing it anything, but we're going to return a double. And we want to close this out. And then in here, we're going to return this dot gas level. As simple as that. Ooh, got an extra comment in there somehow. All right, and then over here, the last method we want to do is we want to create a method for the set gas level. So we public, and this one is going to return nothing. So we're going to void that and then set gas level. And this one we're passing some parameters. We're going to say a double that is the new gas level. And we'll just call it GL and gas level since we've gotten it in the UML that way. That way this will match the UML completely. All right. And we want to say some logic around here. So we probably want to do something in here to get some logic. So when we set the gas level, no, we're going to actually go ahead and let this gas level be the new gas level. So let's go ahead and copy that into here. That's our final gas level. From here, I'll go ahead and let's go switch to the one I've already written, since it's already pretty much commented out in good ways here. We've got the private final string model, private double gas level, and we've got the mower that we're creating. So to do the constructor here, we want to say this dot model equals M for that string. This dot gas level equals G for the other one. And we're going to go ahead and do that. Last thing we want to do probably here is we don't have in here a mow method, but we would want to create a mow method. And so this mow method is going to say if the gas level is greater than 0, then we can say mow, 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 I'm mowing. And then say this dot gas level minus equals, so we're subtracting 0.5 every time we mow. And then otherwise, if the gas level is at 0, we can say glub, 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 no gas, and we can't mow. So, and if it's less than 0, we want to set the gas level equal to 0, because we know that we can't have negative gas levels in a lawnmower. So that's how we'll do mowing here. And then if we wanted to, we could create a main method that would test this by doing a couple of items here. Let's go ahead and do that. Or we could create a lawnmower driver file or a mower driver file that would represent that as well. Let's go ahead and save those and get back to here. So one thing we could do is we could either go in here and create some tests for this using a mower test and come in here and do some of that, or we could come into here and write a main method. In this one, I might just go ahead and write a main method instead of doing the test, because the main method would probably be quicker to do. But if you were doing a bigger item, you would probably want to set up tests and do the test and make sure you are coming up with good test cases. That's something you really want to start to understand how to do, is to come up with these edge test cases, especially around arrays. So we hopefully have started to see you want to kind of deal with the null values for arrays. What if the array is set to null? What if the array is empty or 0 for a length? And then you want to handle elements that are, what if your target element is at the first element? What if it's at the last element? And then what if it's somewhere in the middle? So you often want to have at least 3 items. Probably 5 is a better test for an array, because then you've got a couple of items in the middle that aren't the target element. So you'd have things where you'd want to test 0, 2, and 4, the 0th element, the second element, and the 4th element in a 5-element array. So those are the ones you'd be interested in looking at. So make sure you understand how to set up these tests that will give good coverage to your code. In homework 10, I think a lot of you ran into issues where you weren't testing for these edge cases. And so figuring out these edge cases is something that you're going to need to develop a skill for as you go through. And especially in 159, I think that's where you're going to get a lot more in depth into that process. So I won't go into too much there. So let's shift over and go into, now that I've gone over that example, the actual, where'd that go? To the other screen. All right, let's go into the lab here. So this alien lab, Lab21. I'm going to set this up for you and start this for you. So this is the idea of this is, and this movie came out a while back, the idea of the Men in Black, and we're back to now just having a sequel to that, the Men in Black International. So the idea is there are aliens among us, and that all these Hollywood stars could be aliens, or other creatures could be aliens, as we look at dogs and other things along the street. So what we're going to try and do here is simulate a alien tracker application, or we're going to track where these aliens are located. So for the lab submission, what I want submitted, I think in here there are, this lab22.txt has several questions here. I'm only asking for the answers to a couple of these, but you'll want to kind of walk through this to understand what's going on in the lab. And then I'm going to be collecting the answers for, I think, 4 of them. So you'll need to submit those 4 in Canvas as a part of the homework submission. So under Lab 22, that there are 4 questions that you'll need to submit by Sunday to get full credit for that portion of it. And then you'll need to submit your files here. Alien.java is the only one we want. So alien.java is what you'll need to submit into AutoLab to have that graded. So make sure you submit that piece in for grading to AutoLab by Sunday. Again, I would try and get these done early so you can get started on the actual programming assignment. Over here, the programming assignment is here. You should read through the specification here. This item here is not showing fully on the screen, so in order to get it to do that, just come over here and right-click and open image in the new tab kind of thing, and you'll see the entire UML diagram here. So for some reason, it's just not behaving well on this particular page, and in order to have it be full size, I had to throw in an image that's a little bit bigger. I'll try and fix this in the next day or two, but just in case I don't, you can know that you can do this and just get to the full diagram there. So, and then you've got several different items here to download. These are all .class files. These .class files need to live in the same directory as your main class, your slice class, and your Word utilities and word clue classes. These are all classes that you're creating down here. And then these other classes, the game board tile, guest field, and the file utilities all are compiled, pre-compiled class files, and they need to sit in the same directory as your files in order to run. So make sure you do that when you pull those down. Again, part A is due this Sunday. It's just some questions based on the write-up here. So you'll need to make sure you understand this portion here. This 7 Little Words is an actual game you can play out here on the web. I haven't seen the latest. So you've got different clues here. It's kind of like a reverse crossword puzzle of sorts. So it's giving you basically these 10-letter clues here, and then you've got to come up with what the actual thing is. So we know Prince Harry's wife Meghan is Markle, so we'd go Markle, and then that would get the successfully put into there. So this is what the game will simulate, and so this is kind of like a crossword puzzle and a combination of that and maybe a word search kind of Scrabble-ish idea. So that's what you'll do, and you'll collect these word slices here from the word, and then you'll put together a word, and it'll, once you've connected the word together, it will actually cross them off over here in the game. Our game works a little bit differently, but not that differently. So in here, when you get the GUI running here, you can have the GUI here. There's 2 versions of this graphical interface. There's the game board here, and then the game board Mac version. So that doesn't have the blue buttons here because it was creating some issues in the Mac side of things. So if you have a Mac, make sure you download the right game board here if you want to play the game out to try and test it. All right. That said, let's go ahead and go into here, and we've got the Alien Lab we want to go into here. So inside the Alien Lab, what we're going to do is download a copy of location.java. I'm going to go ahead and open it in a new tab. I'm actually going to create a project over here, and let's go Lab22 in here, file, new Java project, Lab22, Spring 20. Finish. Okay, no source files exist. I wouldn't think they would. Spring 20. Come into here, and let's go ahead and we'll go right click, new class, and we're going to call this one location. And we're just going to go ahead and create that because I don't need to worry about it, because I'm not really worried about actual item in there because I've got code that I've already written that I want to use in here. So paste that into here. I'm going to save this out. So we've got this location one saved out, the class there. Close that. And then I want a copy of this, mib.java. All right. I'm going to go ahead and new class here. And I'm going to go into here and call this MIB. Finish. Save that. And I've got the next item here, which is the alien.java. And I want to grab that. That's the one that we're primarily going to be concerned with. So new class. We'll create this in Lab22. We'll call this alien. Hit finish and paste this in here. All right. Now all of these things will compile. This is compiling, and then over here we've got an alien. So first thing you want to do is really come in and understand these classes that we've given you. So we're going to review the code for location.java, and we're going to take a look at that and answer the questions on the sheet. I won't do the answers for those, but let's take a look at this. So we're going to look at this. This location class is creating 2 constants. So JMU will be this location, and this is a lat long location, latitude, longitude. And then we've got this ISAT location over here too. So we've got two separate locations here that are constants that we can use. So we can say location.jmu, and that will give us the location for JMU. And then we've also got location.isat, which would give us the location of ISAT. So we can put people at JMU or at ISAT. And then we've got these ideas of this latitude and longitude as the two attributes that we have here. Over here, we can set a location. This is the explicit constructor for location. We're going to pass it a latitude and a longitude and set those lat and long inside of our new location object. So then we've got this are the two values within 0.00001 of each other. So if they are, then they're equal. So this dot latitude minus other dot latitude is less than or equal to 0.00001. Then we are in fact equal. And so these two locations, the other location and this location, are equal if these lat and long are within this tolerance of 1/100,000, I think is what the value of that is. Then for a two-string, we have a format where we're printing out the latitude and the longitude with 6 characters. So we would have this 38.435427. That's what we're going to print out here for us with .6 after the decimal point. So that's the location class. Let's go ahead and take a look now at the next one. Okay, we've got a main method in this mib.java. Review the code for alien.java, and let's answer the questions on the worksheet. Okay, for here, we're going to go take a look at this alien.java. In here, we want to write our class description for alien. Java Lab22, simulate an alien detention center. All right. Then you want to put your name into here and today's date into the version or the due date. You can go / what is it? We're doing 19, I think, or 21 is the due date. So then we've got this alien class. For aliens, we have an alien count in here, just like that circle count in the circle class. And then we've got a rogue count here. So not all aliens are rogues. So those numbers may or may not be anywhere near each other. For sure, the alien count will be at least equal to the rogue count because we can't have rogues that are not aliens. So these two will at least, alien count will at least be equal to rogue count, if not greater than. So it's greater than or equal to rogue count at all times. So inside of this alien class, we've got a name for the alien. We've got their home planet, their location that we're going to reference this class here, location. We've got an alias that they call themselves on Earth, and then we have a wanted or not wanted. So if we're looking for them, or if they're rogue, they're wanted, and therefore wanted. If that is true, then the rogue count needs to be incremented. All right, we've got our default constructor here. We know we have an alien, but we don't know much about it. This method calls the explicit value constructor, and it basically is setting the pieces to this, and we're going to set them to unknown for the name, unknown for the home planet, location to ISAT, and unknown for the alias. And then by default, the Boolean here will be false. So that's the explicit constructor. This is going to create and set up an alien that is unknown here. Then we've got the explicit value constructor where we're going to set these things out, and we need you to create and finish this one out. So this is the piece that you're going to start writing, which is the alien constructor. Then over here, we've got this captured. You're going to have to write this one as well. So I might do this, finish me. I'm going to do another one down here, finish me. And over here, the deport, finish me. This is all stuff that you'll need to write in here. Finish me. move again here, finish me. And then same down here. Again, these are not very long of methods, most of them. So maybe about 5 to 10 lines max. And over here, we've got a toString that we've done for you. So this one's complete here, and it's going to print out the aliens information. So now I can come into this MIB. Let's go ahead and run this and see what we get here. Okay, I'll save that. That's fine. Okay, so I've got a compilation problem, get number of aliens. Okay, so that does not return anything. So I need to at least come in here and do the return. So let's return 0 here as an integer because we need an int coming off of this one. So it'll compile. Let's see whether we can get this to run now. Okay, get number of aliens, and then no, number wanted. So we need get number of aliens here too. And let's go ahead and return 0 here. All right, we'll save that out. Then we should be able to come into here and run this. Yes, okay. So this is going to give us in this main here, we're doing a bunch of different things. We're setting up an alien named Frank, an alien named Bug, and we're coming into here and we're setting up explicit values for this alien and constructing them. And then we're saying aliens now 1 and alien.get number of aliens, and that is 0, but it should be 1 because we have, or 2 actually, because we've created 2. So we're going to want to make sure we write these so that these things come out to how they should be at the end. I think I have given a solution output. So at the end of the day, when you're done this is what your output from the solution should look like. You should have 2, 0, 2, 1, 4, and et cetera, et cetera. And then over here, you'll have different latitude, longitudes, and home planet descriptions when you're done and everything is working. So that's how you can validate everything is working properly, by looking at the expected output here. And so you'll need to stub in everything else and then finish out the methods. I will be around for a little bit longer for office hours, and I'll let you guys get to this one. And then on Thursday, we'll go through Lab 23, which is the houses lab. And then I'll also probably try and give you a little bit of starter material for the programming assignment on Thursday as well. So that's all I have here for class. I'm going to go ahead and stop the recording here, and then you can go ahead and